Hi, this is Sean, and this is my first-person shooter spatial audio and technical sound design demo reel made in Unreal and Wwise. This demo uses the Google Resonance plugin for HRTF-based 3D spatialization. Headphones are required to experience the full spatial effects. I will begin with gameplay footage and do a detailed breakdown at the end. Hope you enjoy it. Thank you for watching. For the breakdown, I'm going to start with the Footstep sound design and implementation. So let's dive right into it. Using a layered approach, I designed unique footstep sounds for each surface type in the game. In this environment, I had surfaces like a snowy mountain terrain, ice, snow, water, and two different types of metals, metal plate and metal grate. Each of these surfaces needed its own distinct footstep sounds to really sell the atmosphere and give weight to the character. For example, for the mountain terrain, I layered in earthy thuds with crunchy snow, gravel, and rock sounds to represent the rugged ground. For metallic surfaces, I used a combination of solid resonant impacts to capture that hard, reflective quality you would expect from a metallic surface. In addition to the core footstep sounds, I added an extra layer of subtle environment-specific movement sounds to enhance the immersive quality of each surface. This movement layer was designed to capture additional ambient details that would naturally occur in these environments, giving each surface type a unique character and added depth. For example, the metal surfaces have an additional metallic rattling and squeaking layer. This simulates the sound of loose panels or pipes resonating with each step, which you'd expect to hear in an industrial metallic setting. For the snowy mountain terrain, I created a debris layer with small stones and pebbles rolling down slopes. Each step has a chance to trigger this layer, making it feel like the character's movement is disturbing loose rocks adding to the rugged and unstable nature of the terrain. For the ice surfaces, I added a crackling layer where you can occasionally hear the ice beneath the character's feet beginning to fracture. This subtle crackling adds an element of tension, especially in icy areas where every step feels precarious. Each of these movement layers is set to trigger randomly, with a certain percentage chance, so they don't play with every single step. This approach keeps the experience dynamic and prevents the sound design from feeling repetitive or overly predictable. Instead, the player experiences these sounds sporadically, which makes the world feel more alive and responsive to their movement. Since it's a first-person shooter, I envisioned a character who's a military figure with heavy boots and gear. I wanted to capture the sound of the character's movement and gear to add a deeper layer of immersion. To do this, I recorded Foley sounds using my winter jacket and a backpack, which I used to simulate the sound of fabric and gear shifting with each step. These sounds help to emphasize the weight and presence of the character, especially in moments when they're moving through challenging terrain. There's also a cold, breathing sound effect that kicks in when the character steps outside in the winter storm. By layering these movement sounds over the footsteps, I was able to create a more complete sound profile that feels grounded and realistic. For the Footstep implementation in this project, I wanted to take a different approach. In my previous projects, I've relied on animation notifiers to trigger footstep sounds, but this time, I wanted to make things a bit more data-driven and explore alternative methods. I aimed to avoid animation notifiers to see if I could achieve a similar level of synchronization and control without depending on them. Another important factor was performance optimization. I specifically wanted to avoid using the event tick, which can become performance heavy, especially in projects where multiple systems rely on frequent updates. Instead, I opted for a combination of enhanced input action mappings and timers to post the footstep events from Unreal to Wwise. The core of this setup involves setting up an enhanced input action that triggers each time the player initiates movement. This input action then interacts with a timer that controls the rate at which footstep sounds are played depending on the character's movement state, whether they're walking or sprinting. Now, when it comes to adjusting the timer rate dynamically, I found through Unreal's documentation that there's no direct way to modify an existing timer's rate. However, it is possible to clear a timer and then create a new one with an updated interval. So whenever the player switches from walking to sprinting or vice versa, I first clear and invalidate the existing timer and then set a new timer with the new appropriate interval. This allows me to change the footstep rhythm seamlessly to match the character's speed. Next, I focused on precise positioning and accurate surface detection to enhance immersion. First, I set up a positioning system to ensure that each footstep sound originated exactly at the character's foot location. To achieve this, I accessed the left and right foot socket locations from the character's skeletal mesh. This allowed me to position each footstep sound at the exact point where the foot makes contact with the ground. I also set up a mechanism to alternate between the left and right foot after each step, creating a natural walking rhythm that matched the character's movement. For surface detection, I used a line trace by channel to cast a ray downwards from the character's foot with each step. When the ray hits the surface, I used the break hit result node to get detailed information about the impact, including the physical material of the surface, and then used Wwise's set switch function to pass the detected physical material as a switch value, which triggered the appropriate footstep sound from my switch container in Wwise. In practice, this setup lets me avoid both animation notifiers and event ticks, resulting in a more optimized and data-driven approach. I found this method efficient and reliable, and it's something I'm likely to develop further and use in future projects when performance and adaptability are priorities. And now for the fun part. Let's dive into the weapon sound design and implementation process. I took inspiration from Mark Kilborn's approach to designing gunshots, which focuses on layering different elements to achieve a powerful and immersive sound. If you're trying to learn how to do this yourself, I would highly recommend watching his video on the Pro Sound Effects YouTube channel. The gunshots are divided into 6 layers: mechanical, transient, body, kick, tail, and lastly, bullet casings that respond to surface detection. This breakdown gave me flexibility to shape each element of the gunshot precisely and helped to create a rich, multidimensional sound. For sourcing these sounds, I used the Boom Library's Assault Weapons Construction Kit. Starting with high-quality assets is crucial, especially for gunshot sounds, as they need to feel powerful and authentic right from the start. Boom Library's sounds provided a solid foundation to build upon. Once I had my layers, I combined them, processing each one individually to ensure clarity and impact. I used a range of effects and plugins, including equalizers, compressors, transient shapers, analog saturation modelers, and subharmonics to bring out the unique qualities of each layer. The mechanical layer emphasized the internal workings of the weapon. The transient layer captured the sharp attack of each shot. The body layer added the main weight. The kick enhanced the low-end punch. And the tail provided the ambient decay, giving a sense of the environment the character is in. This layer plays a key role in situating the gunshot within the game's world, with different tail designs for indoor and outdoor areas to match the space. Now, although the Boom library provided some great options for reverb tails, I felt the need to create something more fitting for the indoor metallic environment of my scene. One really good thing about the library is that it includes impulse response triggers, which can be used with custom impulse responses and convolution reverb to craft your own unique reverb tails. I ended up going down this route. I found some very interesting, unique impulse responses captured at the Chatham Dockyard inside submarines and warships. I combined 2 impulse responses that I really liked. One captured in the HMS Cavalier, a C-class destroyer of the Royal Navy that served in World War II, and the other from the HMS Ocelot, an Oberon-class submarine. These impulse responses gave me exactly the kind of industrial, reflective, but hollow, metallic, convolution reverb sound that I was looking for, adding a sense of depth and authenticity to the gunshots in the indoor environment. In Wwise, I set up each layer with variations to keep the gunshot sounds dynamic and prevent repetition. Each layer had multiple variations, all loaded into their respective random containers, parented by a blend container, which allowed all the layers to play together seamlessly. For the reverb tails, I used a switch container to handle the different environmental settings. This setup let me switch between indoor and outdoor reverb tails dynamically based on the character's state, so the weapon sounds would adapt perfectly to the surroundings, enhancing immersion across different spaces. Lastly, for bullet impact sounds, I wanted each type of surface to have its own unique sonic profile. I set up surface detection to identify which material the bullet hit, allowing for tailored impact sounds across different surfaces. This included two different types of metal, each with distinct tonal qualities to capture variations in resonance, as well as mountain terrain where impacts produced earthy, gritty thuds. For water, I created splashes that mimicked bullets hitting shallow puddles, while ice impacts included subtle crackling, adding tension to each shot in icy areas. Finally, snow impacts were softer, with a dampened quality to match the sound absorbing properties of snow. This surface specific approach helped make each shot feel grounded and responsive to the environment. In addition to the impact sounds, I've also added bullet whiz and ricochet sounds to capture the sense of bullets traveling through the environment. The whiz sounds add a sense of danger and proximity as bullets pass by, heightening the tension for the player. For ricochets, I implemented a probability-based trigger system so that not every bullet impact results in a ricochet. Now personally, I'm a big fan of using Ambisonics for designing dynamic ambiances. I feel like using evolving sound fields really adds to the depth and immersion of the overall experience. I used the Envelope for Live spatial audio toolkit to design my ambiances. The outdoor area has two ambisonic assets, a heavy and a light winter storm. Both assets were loaded into a blend container in Wwise with RTPC controls tied to weather states that adjust depending on the player's location in the scene, providing a seamless and responsive outdoor experience. For the indoor area, I designed an evolving industrial ambience that reflects the metallic, industrial feel of the space. This ambience includes sounds of resonant metal pipes, moving machinery, and other metallic elements to capture the character of the environment. The result is a dynamic layered soundscape that enhances immersion, adapting to the player's movements between indoor and outdoor areas. In the final stage of this project, I focused on accurate geometric acoustic modeling to ensure that the environment sounded as realistic as possible. Using Wwise's Room Verb plugin, I created two distinct reverb zones for the indoor and outdoor areas, tailored to match the psychoacoustic properties of each environment. For dynamic early reflections, I used the Wwise Reflect plugin along with AK Spatial Audio Volumes and AK Geometry components to convert all scene and mesh data into spatial audio geometry. By setting up and configuring AK Spatial Audio Volume actors in Unreal, I was able to generate reflections that dynamically adjust to the geometry of the space, making each environment feel acoustically accurate. I carried out volume fitting with Unreal Engine's modeling tools to fine-tune the shape of the acoustic volumes, allowing me to closely simulate the indoor area's physical boundaries. I also applied AK acoustic textures to send specific surface material information to Wwise's spatial audio engine, allowing Wwise to accurately simulate the material characteristics of each surface. For even greater realism, I set up diffraction and transmission features in Wwise to model how sound propagates, diffracts around objects, and transmits through materials. Lastly, to handle sound leaking from one environment to another, such as through open doors or windows, I used AK acoustic portals. This allowed for smooth, natural transitions as sounds move between spaces, creating a truly immersive and cohesive audio experience across the entire environment. My name is Sean, and this has been my first-person shooter spatial audio and technical sound design implementation demo reel. Thank you for watching.